please try this question. So in some questions, we don't need to find the critical points because interval will always be given in the question. Okay, in some questions, they will give you the interval. For example, in this question, they have given you the interval 0 to pi, pi to 2 pi, and 0 to 2 pi. So there's no need to find the critical point for this. So just differentiate this and check that for this interval 0 to pi, for the second interval pi to 2 pi, and for the third one, it is increasing, not decreasing. Okay, I will give you 3-4 minutes for this question. Please complete it and share yours. Let me know if anyone have a doubt in this question. Hello, Abdur. My voice is audible. Abdur, my voice is audible.
Yes.
Okay, so Abdur, please try this question. Okay, and raise your hands once it is done. So in this question, Abdur, in such a type of question, there is no need to find the interval. There's no need to find the critical points because the interval is already given in the question. So you just need to differentiate it and need to check that for these interval, it is strictly increasing, decreasing, or what. Rifat, Fahad, Abdur, is it done? There's a very simple question. Okay, Rifat, very good. So Rifat, A, B, okay, good. Fahad, is it done? Okay, Fahad, you need help in this question?
So we,
Sorry, Abdul, your voice is not
so
audible.
we just need to prove it.
We just need to prove this. Okay, I will solve this. So here we have fx is equal to cos x differentiated. So we will get a minus sin x. Okay, so minus sin x. So strict for x belongs to 0 to pi. 0 to pi.
So first we put x equals to 0, right?
No, there's no need to put x is equal to 0. Okay, because the interval is already given, so we will not find any critical point. We have this complete interval, so what we can write for x belongs to 0 to pi. Okay, Abdul, so 0 to pi means first and second quadrant. So Abdul, can you tell me this sin x is what in the first and second quadrant? It is greater than
So
0.
positive.
Positive. So this is greater than 0. So this implies if you will multiply with a negative sign, the inequality will change. Okay. This implies f dash x
So how
is
did we change inequality?
okay. In class 11th, you have done the inequality chapter. Okay. So please remember, whenever you will multiply or divide any inequation with a negative number, whenever you will multiply or divide an inequation with a negative number, the sign of inequality will change. Okay, Abdul?
Yes, sir.
Okay. So f dash x is less than 0. This implies fx is strictly decreasing in 0 to pi. Okay. So this was the first part. In the same way, please try to do the second part. So if okay, please first of all, Abdur and Fahad, complete the first and second. Please complete the second part and raise your hands. Okay, Abdur, very good. Fahad, is it done? The second part? Fahad, second part is done?
So can you explain part
Yes.
C?
First of all, we will check the part B. For pi to 2 pi, so this means the third and the fourth quadrant. Third and fourth quadrant. Okay, this is pi and this is 2 pi. So for, can you tell me for this interval pi to 2 pi, sin x is what? Greater than 0 or less than 0?
So sign will be positive.
No, this will be
Less
negative.
than 0, negative.
Less than 0. Okay, remember in this way, for all school to college. Okay, remember this way, all school to college. So all means all ratios are positive. S means sine and its reciprocal, that is cosec. It is positive. T means tan and its reciprocal, cot is positive. C means cos and its reciprocal, that is sec is positive. So in third and fourth quadrant, in third quadrant, tan cot positive, rest are negative. And fourth, cos sec are positive, rest are negative. Is it clear, for?
Yes, sir.
Okay, so sin x is less than 0. Okay, so that means minus sin x will be greater than 0. Sign will change. So this implies f dash x greater than 0 and fx is strictly increasing in pi to 2 pi. This clear for now?
Yes, sir.
Okay, great. Now the third one. Third, they are saying neither increasing nor decreasing. So I guess we have discussed this from 0 to pi. So you can, for the C, you can write for 0 to pi. fx is what? Is strictly decreasing. For pi to 2 pi, fx is strictly increasing. Okay, I will write complete strictly increasing. So what about this in complete interval? 0 to 2 pi is 2 pi is strictly decreasing, pi to 2 pi is strictly increasing. So for 0 to 2 pi, neither increasing nor decreasing. Neither increasing nor decreasing. Is it clear? Is it clear for?
Yes.
Oh, okay, Abdul. So you are saying all students take coffee. Yes, this is good. Okay, so from next time I will use this. All students take coffee. Okay. Okay, so Zed, you have joined 20 minutes late. Zed, please join at the correct time for the next class. Okay. Okay. So Zed, we have done this question number 7. Okay. So Zed, you can take a screenshot of this question. Okay, and try to solve it later on. In case you have any doubt, then I can help you, but you can do this question. Okay. So please let me know that once you have taken the screenshot. Okay. Now next question. Find the interval in which this one. Okay, this is quite. Okay, please try this question. Find the interval in which this function given by fx is equal to sine 3x is increasing and decreasing. And all of you, please complete the assignment. Okay, assignment of increasing, decreasing, and rate of change. If anyone have a doubt in this question, please let me know.
Sir, in this, should we equate with 0?
Yes, you have to find the critical point. Okay. Because they have given their limit that you need to find in this, but you have to find the critical point and divide that in the intervals. Everyone, please share the critical points if you have find for this question. Okay. Okay, Fahad, I will help you. So please check here. We have fx is equal to sine 3x. Okay. Anyone, Rifat, Zad, and Abdul, did you get the critical points?
No, sir.
Okay, please check here. So here we will get 3 cos 3x. Good, Zad. That is correct. Very good. Now please check for increasing and decreasing Z. Put of dash x is equal to 0 to find the critical point. To find the critical point. Okay. So put this 3 cos 3x is equal to 0. Okay, observe critical point is -1. No, observe the critical point will be in terms of angle. Okay, please check here. This is equal to 0. So first cos is 0 for which angle? First cos is 0 for which angle?
So how did you get cos 3x?
Cos 3x. We have differentiated this sine 3x. Observe. What's the derivative of sine?
So we have 3 cos 3x, right?
Yes, we have 3 cos 3x. So we have equated this with 0. So 3 will go to the right side. It will become a 0. So we will get cos 3x is equal to 0. Is it fine, Abdul?
Yes, sir.
Okay, so Abdul, can you tell me an angle for which cos is 0?
So cos 90.
Cos 90. 90 means pi by 2. Okay. solve this. So what we will do, equate 3x with pi by 2. So what we will get here, x is equal to, shift this 3, we'll get a pi by 6. Okay. This pi by 6, we have this interval. Okay. Whatever the value of x you will find, that should lie in this interval 0 to pi by 2. So x is equal to pi by 6 lie in this. So that is fine. This is one of the critical point. First, this is clear. This clear
Can you
for
explain that last line?
last line? Yes. For cos is 0 for which angle?
90 degree.
90. So we have put cos pi by 2 here. Okay, equate these two. So you will get 3x is equal to pi by 2. Shift this 3 to the right side. You will get a pi by 6.
Then after that, cos gets cancelled.
No, not cancelled. We say in this way that LHS is equal to RHS. Okay. When LHS will be equal to RHS, when their angle will be equal. Here we have a cos, here we have a cos. So these two angles should be equal. So that's why we have put 3x is equal to pi.
Okay.
Okay. So we get x is equal to pi by 6. So whatever the angle you are finding, whatever the value of x you are finding, please check that should lie in this interval. Okay. So first angle we have used is pi by 2. We get this. Again, we have we have cos 3x is equal to 0. So anyone can tell me, Abdul, can you tell me any other angle for which the cos is 0? I guess this we have already discussed some days back, where I showed you the complete chart. So anyone can tell me the value of the angle for which the cos is 0.
Cos 120.
Not 120, 270. Okay, cos 3 pi by 2. Okay, this you have. There's a 0, pi by 2. Please learn all the values. Please remember that chart which I showed you and some days back. This 2 pi. So if cos is 0 for this pi by 2, okay, then cos will also be 0 for 3 pi by 2. Cos 3 pi by 2 is also 0. So cos 3x is equal to cos 3 pi by 2. We get this. And from this, okay, now check here. X is belongs to 0 to pi by 2. Okay, this is x. This is 3x. So we can take the angle 3 pi by 2. 270 we can take because this is x. And here we are talking about 3x. So from this, we will get 3x is equal to 3 pi by 2. Cancel 3. You will get x is equal to pi by 2. Okay. So what the interval you will get? You have 0. You have pi by 2. So these two you need to take in. Third angle you get pi by 6. So what the interval you have 0 to pi by 6, then pi by 6 to pi by 2. So here 0 is included because it is given in the question. Pi by 6 we will include because it is increasing. Again, pi by 6 include, pi by 2 also include because it is increasing. So we get these two intervals. So all of you, please check for these two intervals that it is increasing and decreasing or not. Okay. So Z, you have already find out the angle. Now please tell me for which interval it is strictly increasing and for which it is, sorry, for which it is increasing and for which it is decreasing. Good, sir. That is correct. Very good, sir. That is correct. Rifat, please share your answer if it is done. And Abdur and Fard, once it is done, please share your answer. Yes, Zed. I have already shared that test paper on the group. Still, they have not added you in the group. Okay. Okay. Zed, will you please again send your number? I will share with them. Okay. 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 Just give me a minute. Yes, for to find the critical point. To find the critical point, we have equated f dash x is equal to 0. Okay, that's why we are finding the angle for which the cos is 0. No, Abdul, that is not correct. Okay, Zat, I will share. Okay. Uh, so I'll form this table. Okay, the interval is what? 0 to pi by 6 and pi by 6 to pi by 2. Okay, so take an angle. What is this? 0 to 30. So take 45. Take x is equal to, sorry, 15 degree. So what f dash x you have? F dash x is 3 cos 3x. Okay, Z, I will do that. F dash x is equal to 3 cos 3x. So put the angle here, 3 cos 3 into 15 degree. So you will get cos 45 degree, 3. It is positive. Okay, Abdur, it is positive means it's strictly, sorry, increasing. Abdur, again check your calculation and tell me for the second interval, pi by 6 to pi by 2. Rifat, if it is done, then please share your answer. And Fahad, please check the second interval, pi by 6 to pi by 2, and share your answer. Rifat, is it done?
So how do we get that 15 degrees?
Well, we have this interval, okay, 0 to pi by 6. 0 to pi by 6 means 0 to 30. So select an angle between 0 and 30 so that we can check that f dash x is positive or not for that angle. So we need a standard angle. We have selected 15 degree. Why? Because when this 15 will get multiplied with 3, we will get a 45 and we know the value of 45. Is it fine for?
Okay.
Okay. Now please check for the next one. What is
So
pi by
increasing.
for the second one? Abdul?
Yes, yes, sir.
No, that's not correct. Abdul, which angle you have chosen? The pi by 6 means 30 and pi by 2 means 90. So which angle is selected, Abdul?
So 45.
45. Put the 45 here. So cos 3 into 45. So what you will get? 3 into cos 135. So what's the value of 135 degree for? No, sorry, Abdul. Pi
Yes,
by
sir. Positive.
positive. No,
0.
no, it is not 0. You can check in this way. 135 degree. 135 degree line which quadrant? For second. In second quadrant, cos is what? Positive or negative?
Negative.
Negative. Negative. So this will come out negative here. Whatever the value you will get here, this will be negative. Is it clear? Abdul, why you were getting positive here? Abdul, did you
Yes,
check
sir. I
here?
did a mistake.
Okay, I guess the mistake you have done is you have checked this interval, this line, the first quadrant. That's why you are going to write the positive. Please check the angle we have is cos 3x. Okay, here you have the value of x. So if x is 45, cos will become 135, 3 times. Okay, first, is this clear?
Yes, sir.
Okay, so there's no need to find the perfect value. We just need to check the sign. So you can analyze in this way also that 135 in the second quadrant, it will be negative. So this will be decreasing. Okay, so shall we move to next question, Fahad and Abdul?
Yes, sir.
Okay,
1 minute, sir.
okay. Scroller. Okay, Zed, yes, I will share that test paper shortly with you. Okay. Okay, actually, I've deleted that. So I will find out your test paper and again share it. First, is it done?
Yes, sir. Done.
Okay, great. Okay, so we have completed this question or not?
No, sir.
No? Okay, okay. Then please try this question. You need to show that this is increasing function throughout its domain. Please complete it and let me know once it is done. Or if you have any doubt, please please tell me. Yes, Abdur, we need to use the quotient rule for that part. Rifat, please complete this question and let me know if you have any doubt. Okay, we have proved this. Okay, Zed. Very, very good. Always increasing. Yes, you are correct. Good. Rifat, Abdur, and Fahd, is it done? Okay, Rifat, very, very good. Very good. Abdur and Fahd, any doubt in this? Oh, no, Abdur. In the question, it is written that this should be increasing. Okay, only increasing. So please check here. We have y is equal to log. When you are applying the chain rule, then please show the complete steps. Please do not miss the steps in your exam. So we need here dy by dx is equal to. So if you will differentiate this, you will get a 1 plus 1 by x, then into 1 minus, right here 2 plus x, different apply the quotient rule. Here you will get 2 minus 2x, you will get 1 by 2 plus x whole square. Here you will get dy by dx, it is equal to, you will get 1 by 1 plus x minus, open this bracket, 4 plus 2x minus 2x by 2 plus x whole square. So cancel out this 2x. So what you will get here, dy by dx is equal to 1 by 1 plus x minus 4 by 2 plus x whole square. Dy by dx is equal to 1 plus x, 2 plus x whole square. 2 plus x whole square minus 4 into 1 plus x. So here you will get dy by dx is equal to, open this, 4 plus x square plus 4x minus 4x by, this is 1 plus x and 2 plus x whole square. Cancel out this, cancel out this. So finally you are getting dy by dx is equal to x square by 1 plus x, 1 plus x, 2 plus x whole square. Okay. Observe, you are getting the same expression.
Sir,
Yes, sir.
sir, in the third step you did reciprocal, right?
First, second, third here.
Third one.
This one.
Not
Or
that one.
okay, next.
Yes, yes.
No, I have not done the reciprocal. Here I have just cancelled out this 2x, 2x. You get a 4 by 2x
No,
plus 1.
in the last part of third step.
Okay. Here I have taken LCM. Okay, for this expression, I have taken the LCM. Okay, for when you will take the LCM first, you will get 1 plus x here and 2 plus x whole square here. Okay, so here you will get 2 plus x whole square minus 4 into 1 plus x. Is there still there is any confusion for in this point? No, I have not done the cross multiplication. I have just taken the LCM here and then I have solved this, the numerator. So when we will get this LCM, then you will divide this with 1 plus x. You will get 2 plus x square. So 2 plus x square will get multiplied with 1. I've just used that simple concept. For example, you have 1 by 4 plus 1 by 3. So what you will do, take the LCM 4 into 3. So this will be divided with this. You will get 3. 3 will get multiplied with 1. Similarly for this. This clear for?
Yes, sir, yes.
Okay. So finally, we are getting this. Abdul, you also get this part, x square by 1 plus x, 2 plus x
Yes.
whole. Okay, great.
So can we open 2 plus x the whole square?
No, there's no need to open this whole square. Okay, because we need to analyze this expression. They are saying that for this one, this should be increasing. So we have to analyze this function. Please don't open this. Otherwise, if you will get a quadratic equation, then we can't analyze. For example, suppose this is x plus 1 whole square. So whatever the value in place of x you will put, there is a square. So this will always be positive. Am I correct, Abdul?
Yes, sir.
But if I will open this x square plus 1 plus 2x, now it is not possible for me to analyze this expression. Okay, so if you are getting a square cube, so please keep that as it is in increasing, decreasing. Don't open it. Otherwise, it will become very complex for us to analyze that expression. Okay, Fad, is it done? Shall we move to next?
So can you explain that last part?
Yes, I can.
Last
So
step.
last step. So here we have taken the LCM. Here we have opened the bracket now in the numerator. So 2 plus x square, a square plus b square plus 2ab. Then open this bracket, minus 4x. So this minus 4x can be cancelled out. 4 and 4 can be cancelled out. So you will get x square by 1 plus x into 2 plus x whole square. Is it clear?
So after that, no simplification.
No, that I will do in the later steps. Is it fine till now?
Yes.
Okay. So we have this one, dy by dx. This is equal to x square. And here we have 1 plus x into 2 plus x whole square. Okay, we have this expression. Now we will analyze one by one. Okay, for x is greater than minus 1. In the question, they are saying this one. For x is greater than minus 1, this should be increasing. So we will analyze one by one. So we have 3 expressions here, this one, and this one. For x is greater than -1, 2 plus x whole square. If you will put any value for x, which is x is greater than -1, okay, I'll draw the number lines so that it is easy for you to decide. This is minus infinite, this is infinite, you have a 0 here. These are not the critical points. Okay, I'm just marking 0 so that you can analyze it. Here you have -2, suppose here you have 10. Now, they are saying x is greater than -1, that means this side. They have not even included -1. So when x is greater than -1, then 2 plus x whole square. For this is always what? Greater than 0, less than 0, greater than equal to, less than equal to what? First, when x is greater than -1, then this expression 2 plus x whole square, this should be what? Any guess for any idea? But any idea? Sorry for you are not audible. No. Abdul, can you tell me for x is greater than -1, 2 plus x whole square is what?
Is it positive?
This is always positive. Okay, always greater than 0. Why? Because it's a square. Okay, fine. There is a
So
square.
why are we taking only 2 plus x the whole square?
We will discuss all these one by one. Okay, then we will decide the final answer. Okay, so this 2 plus x square will be greater than 0 for x is greater than -1. This we have done. First, this is clear.
Yes, sir.
Okay, now next tell me this one. 1 plus x will be what? When x is greater than -1, what will this 1 plus x? Try to put in value. Okay, I will give you
So
1 minute.
positive.
It will be positive. Who's this? Abdul? This is your answer? 1 plus x is what? Greater than 0, greater than equal to 0, what?
Greater than 0.
Greater than 0. Okay, very good. Okay, this is not equal to 0. Okay, because when this will be equal to 0, for x is equal to -1, but we are not including -1. We are putting greater than -1. So 1 plus x greater than 0. Third one, x squared. Fourth, can you tell me this?
Again, greater than 0.
Only greater than or equal to also?
Um,
Yes, sir. Fourth, equal to also or only greater than? No, sure. Abdul, only greater than or equal to also?
Sir, only greater than say.
Only greater than. Please check here. X is greater than -1. Greater than -1 means we can include 0. Okay, so 0 will also come when we will select greater than -1. Now this is in the numerator x squared. So if we will put a value 0 here, this becomes 0. So we can say greater than equal to 0. Why this was not equal to 0? Because x should be -2 for this to become a 0. We can't select -2 as the value of x is greater than -1. So I hope this is clear to everyone. Now we will finally analyze a complete expression. So this implies dy by dx. Please check here. This numerator can be greater than equal to 0. Denominator is only greater than 0. Okay, so we can say for so we can say for x is greater than -1, dy by dx is equal to x squared by 1 plus x, 1 plus x, 2 plus x whole square greater than equal to 0. Hence fx is increasing for x is greater than -1. This is Fahad and Abdul. Further,
Yes, sir.
Abdul? Okay, good.
So how we let us not equal to
Yeah,
0.
for this x square can be greater than equal to 0 or x is greater than -1. We have analyzed here.
So what if we put only 1?
What if,
We put 1.
okay, if we
So
will put 1, then we will get greater than 0. But if we will put 0, then it becomes 0. So we need to write all the conditions. In the denominator, you can't have a 0. There is no value of x for which you get a 0 because x is always greater than -1. But in numerator, you have both the possibility. You will get a greater than 0 and you can get a 0. Clear up to?
yes, sir.
Okay, very good. So please note down this. Abdur and Fard, raise your hands. Then we will see the next topic. And tomorrow you have a test of increasing and decreasing and rate of change of derivative. Okay. From application of derivative, you have a test, rate of change of quantities and increasing and decreasing. Okay. Okay, Abdur, great. Fard, is it done?
1 minute, sir.
Okay. Yes, Abdul. Same pattern, 3 questions, 30 minutes. Right. 1 question is from rate of change, 2 questions from increasing and decreasing. Uh, is it done for?
Yes, sir. Done.
Okay, great. I think we have already done this question, no? Question 10. Okay, Lord, we have done this question last week. Anyone can tell me, Rifat, Abdul, Fad?
Yes, sir. We
That
did.
we did. Okay.
Yes, sir, we did.
Okay, thanks. This also, I guess, we have completed. Yes.
No, sir.
No.
No, sir. This we did.
Okay, then this is a homework. This is a very simple question. Okay. Neither increasing nor decreasing. That means inside this interval, there is some portion for which you get a strictly increasing, for the rest you will get a strictly decreasing. That's why you will say that neither increasing nor decreasing. Okay. Today we have to start the maxima and minima. So please note down this. This is your homework. In case you have a doubt, please let me know. But I'm sure you can solve this question. This is a very, very simple question. Okay. So please again raise your hands once you noted down this and try this in homework. Okay, Rifat, very good. Abdul, Fahad, Zad, please note down this and try this question in homework. Okay, Fahad. Abdul and Zad, is it done? Okay, Abdul, good. Zad,
So,
is
sir,
it done?
-1 and 1 is the what we say internal
Yeah,
critical points, right?
no, these are not the critical point. This is the interval they have given.
Intervals. Yeah, yeah.
Yeah, so you need to find the critical point by differentiating it. Okay. Okay, so everyone has done this. Okay. Okay, this is also homework. Okay, very straightforward question. Interval is given. You just need to differentiate it and you need to check the answer. Okay, so there's a straightforward question. Please note down this. And again, raise your hands once it is done. Okay, this is a very, very simple question. Okay, Fahad, very good. Abdul, Rifat, Zaid, is it done? Okay, good, Rifat. Good, Abdul. Very good, Zaid. So that function is, just give me a moment. Okay, it's a tough question we will do in the class. So please try this question. The question is, let I be any interval disjoint from -1 to -1. Okay, what is mean by this statement? Anyone can tell me what is mean by this statement? Disjoint from -1 to -1. Rifat, can you tell me what is the meaning of this? Rifat, can you tell me what is the meaning of this statement? No? Zed, any idea what is the meaning of this? Disjoint from -1 to 1. Anyone can tell. Yes, sir. You're saying something? First,
I
you
have no
was
idea.
okay, no idea. Disjoint. Okay, so disjoint means what? You have this complete real number R. So they're saying I be any interval. Disjoint from -1 to 1. That means I be the interval, the complete real number line, except -1 to 1. So the interval which you have is real number except -1 to 1. Okay. So what I suggest you is to differentiate this, form that interval, find the critical point, find that interval, then we do analyze it. Okay, I will give you 5 minutes for this question. And in case anyone have a doubt, please let me know. Okay, so you're saying it is strictly decreasing on this? Okay, so what about the rest? Yes, you got 3 interval, that's fine. So for the rest, you are getting strictly increasing. Oh, okay, please check. Okay, Zed, so if you will analyze the part for which you are getting strictly increasing, so that will be this one. Please analyze your answer and this part. So I hope you will get to know that for this one, it is strictly increasing. So Fahd, Abdur and Rifat, did you get the answer? Fahd, Rifat and Abdur? Oh, okay, Zed, very good. Okay, great. So let me solve this. Okay. And Zed, please check here because I think you missed something in this question. This is x plus 1 by x. Okay. Please check here. Uh, you will get to know something new in this question, f dash x. So this will be 1 minus 1 by x squared. So then we will take the LCM. So LCM will be x squared minus 1. Okay, so who can tell me? Rifat, can you tell me what is critical points? What is the definition of critical points? Rifat, we have the critical points in the last class. So can you tell me the definition of critical points?
We should equate it with 0.
Yeah, that's 0. But what are critical points?
X,
Please,
x square minus 1 and x square.
no, that's fine. But if you will turn your pages, check the definition of critical point. Anyone can tell me what are the critical points? Abdur, Fahad, Rifat, Zad, anyone? What is mean by critical points?
So point C in the domain of the function in which f of C is 0 or f is not differentiable at C.
Very good. Very good. Okay, so the values of x for which the f dash x is zero or not defined. Okay, so critical points are those for which the f dash x is zero or not defined. Okay, always remember. So when this will be zero, when numerator will be zero. When this will be not defined, when denominator will be zero. So if you need to find the critical points, always remember, if you have a fraction and you need to find the critical points, then please equate both numerator and denominator to zero. Okay. Please always remember you need to equate numerator and denominator to zero. Please don't miss denominator. Okay, why? Because if you will equate the denominator with zero, this does not exist. And this is the definition of critical points that uh, the values of x for which f dash is zero or not defined. Okay, so we'll like put x squared minus 1 is equal to 0 and x squared is equal to 0 to find the critical points. To find the critical points. Is it clear? Rifat, Fahad, Abdul, and Zad. Okay, Rifat, good. Abdul, Zad.
Yes, sir.
Okay, great. Okay, Fahad, I guess you also understood this point. Now, x square is equal to 1. So x is equal to plus minus 1. One critical point is x square is equal to 0. This will give us x is equal to 0. So x is equal to 0 plus minus 1 are the critical points. Okay. Please don't ignore the denominator. Okay. Now, what are the interval we will get? We will get this interval. This is minus infinite plus infinite, minus infinite plus. Then we have a minus 1. Then we have a 0 and we have a 1. So we will get 1, 2, 3, 4 interval. Okay, Seth? So I guess you missed this point. So please remember. Okay, we will check all the interval. Then finally, as per the question, we will conclude it. Okay. Okay, sir. So first thing is interval, sign, and nature. Interval, sign of f dash, nature of the function. Nature of the function. Okay, so what is the interval you have? Interval is minus infinite to minus 1. Open. Next is minus 1 to 0. Open. Then 0 to 1. Open. And 1 to infinite. So what is f dash x we have? It is x square minus 1 by x square. Okay, so this is always positive. We need to focus on numerator. First, can you give me any number from minus infinite to minus
0.15.
1? No, this one, minus infinite to minus 1.
So -2.
Minus 2, okay. Put here minus 2. So if you will put minus 2 here, this will become 4 minus 1. This is always positive because this is square. It will give you positive. Okay, nature of the function, strictly increasing. Okay. Next, other any point between minus 1 and 0?
So -1.5.
Not minus 1.5, minus
0.15.
0.15. Okay, 0.15, and that is also negative. So if you will do this, put here, so square minus 1 by x squared. So this is always positive. If you will check this part, so this will become less than 1. So definitely it will give us negative, less than 0, strictly decreasing. Next, 0 to 1, any point between 0 and 1, any point? 0.5, very good. Okay, so 0.5, 0.5 square minus 1. This is again less than 1, so this is negative, less than 0. Okay, strictly decreasing. 1 to infinite. 1 to infinite, take any point, for example.
2.
2, so 4 minus 1, this will be positive, greater than 0. So this is strictly increasing. Now analyze this part. This is strictly increasing for which interval? Minus infinite to minus 1, 1 to infinite. Okay, if you will check the question, so they are saying that it's strictly increasing on the interval I. So fx is strictly increasing, on minus infinite to minus 1, and we have already used the concept of union 1 to infinite. So if you will analyze this part, check here. So this is strictly increasing here. So that means for this one, it is strictly decreasing for this one. This is what minus 1 to 1. This complete. For this is strictly decreasing. And what is our and this is what? This is, please check here. It is real number except minus 1 to 1. So this is our interval I. So fx is strictly increasing on this interval, that is on I. I is also this interval, minus infinite to minus 1, 1 to infinite. Please check here, this does not include minus 1 to 1. This is clear? Abdul, Fad, Rifat, Zed.
So, sir, the function is increasing on I.
Strictly increasing?
On I.
Yes, strictly increasing on I. Okay, I've written here fx is strictly increasing on this. That is on I. I is the same thing. Minus infinite to minus 1 union 1 to plus infinite. This is the same thing. That is I. This also can be written as like R except minus 1 to 1. Is it fine, Abdul?
So, can you explain once again, like how it
Yes.
is increasing on I?
Okay, how it is increasing. This is clear, Abdul? Minus infinite to minus 1?
Yes.
Okay, okay. Now check what is this R except minus 1, 1. R means complete number line. Minus infinite to plus infinite. Okay. Here we have minus 1. Here we have 1. Okay. R except minus 1 to 1 means you need to remove this part. This clear, Abdul?
Yes, sir.
Okay. Now for this one, minus infinite to, that means what is left? What we have? This one. And we have this one. So Abdul, can you tell me for this one, minus infinite to 1, minus 1, the function is what?
So, decreasing.
It's strictly increasing. Check the table. Minus infinite to minus 1.
Yes, increasing.
And for this one, 1 to infinite,
Increasing.
strictly increasing. Okay. And what is this? This is R except minus 1 to 1. And what is this? This is the interval I.
Yes, sir, understood.
Good. But this clear?
Sir, numerator will always be positive.
No, 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 no. Numerator
Sorry,
is not.
denominator.
Yes. Why? Because there is a square. So whatever the value you will put in place of in denominator, you will always get a positive answer.
Ah, yes.
Okay. So if this is clear to all of you, please note on this. Okay, then we will close this topic and discuss about the maxima and minima. Please raise your hands once it is done. Yes, Abdul, for this question, okay, because for these two, we get strictly decreasing. Okay. So for this means, except for the interval I, this is strictly decreasing. So except I, what we will get minus 1 to 1. Okay. Is it done? Abdul, Fahad and Rifat, shall we start next? Okay, Rifat. Abdul and Fahad, will you please confirm?
Yes.
Okay, Zach, good. Okay, Abdul. Okay,
Done, sir.
Rifat.
Done.
Okay, great. Now this question is a simple question. Okay, this you can do in the homework. Please note down this. A very straightforward question. Please again raise your hands once it is done.
So we did this.
Okay, we have already done this. Okay,
Yes.
thanks. We will check next. Okay, this is also a very simple question. Okay, this is not a tough. Okay, sorry, I've already given the answers. That's fine. Please mark the answer and try to complete this on your own. In case you will face an issue, let me know. I will solve this. But you can do this question. This is a simple one. Okay, this is also a homework. Okay, Fahd, very good. Abdul, Rifat, and Zad, please raise your hands if it is done. Okay, Rifat, good. Okay, Zad, good. Abdul, is it done? Okay, great. Our next topic is monotonicity. Okay, what is mean by monotonicity? Functions are said to be monotonic if they are either increasing or decreasing. Okay, and please correct this. This is e to the power x. Okay, so functions are said to be monotonic if they are either increasing or decreasing in their entire domain. Okay, if the function is increasing, like this, it is getting increased, we will say it is monotonic. If it is decreasing, we will say it is monotonic. If the function is both, it is increasing, then it decrease, then it is not monotonic. Okay. If the function is both increasing and decreasing, then it will not be monotonic. The same thing I have written here in the second statement. Functions which are increasing and decreasing in their domain are said to be monotonic. That means which are both increasing and decreasing also, then they are not monotonic. For example, sin x, if you will see the sin x graph, and this is squared, okay? This is x squared. So if you will see the sin x graph, it increase, it decrease, decrease, increase. Okay, so that's why it is not monotonic. Similarly for x squared, what's the graph of x squared like this? So it is increasing as well as decreasing. So that's why it is not monotonic. So what is monotonic? Which is either increasing or decreasing, but not both. Okay. So please note down this, raise your hands once it is done. Now we will start the maximum and minimum value of the function. Okay, Zed, very good. Abdul, Fahad, and Ifat, please raise your hands if it is done. Okay, Fahad, very good. Abdul and Fahad. Okay, Fahad, good. Abdul. Okay, Abdul, very good. Okay, so this topic is completed. Now we will start the maxima and minima. Okay. Okay, then we will discuss maxima and minima. But I guess it is better if we will start with the local maxima and local minima. Okay. Maxima and minima. Okay. So what is mean by maxima or the maximum value of the function? If we will see a graph like this, suppose we have this graph. Okay, this is y, this is x, this is your function f(x). Let this is a point C on x-axis. Okay, and for this C, you have the value of the function fc. So if you will see at this point, if you will see the neighboring points for this point C, like this, this is a point C, and this is the value of the function fc. this is FC. If you will see the left side of the points which are there on the left side of C, if you will find the value of the function at these points, then these values of the function are lesser than FC. Similarly, if you will check the points which are right side on the C and you will check the value of the function, then these value of the function are lesser than FC. Okay, so when we will say that this C at point C, the function have the maximum value. If we will check the left side, if we will check the right side, at this point, if the function have the maximum value, then we will say that FC is the maximum value of the function. And this C is called the point of maxima. Point of maxima. Okay, so what is the maximum value of the function? This is nothing new. What is the maximum value of the function? You have a graph, you can check that, okay, at this point, the function have the maximum value, the greatest value. Okay, so this is the maximum value of the function, and this point is called the point of maxima. Okay, is this clear? In a simple language, you already know that what is this topic. Is clear? Abdul, Fahd, Rifat, Seth. For today's class, that 25 more minutes. Okay, sir? Okay, okay, sir. Abdul, Fahad, Rifat, this is clear? That what is the maximum value and what is the point of maxima? Okay, Rifat.
So can you explain again?
Yes, yes. Okay.
I got disconnected.
Okay, no issue, Fahad. Please check here. First, we have this function. We have already drawn the graph of this function. If we will see this point C, that at this point C, the function have the maximum value, the greatest value. Okay, why it is greatest? Because if we will compare with the left side, then this value is greater than our left side, all the values. We will check, then from the right side also, this is the maximum value. Okay, this is nothing new. This is a very simple thing which you already know. What's the maximum value of the function? The greatest value. This clear? Good.
Yes, yes.
Okay. So for this topic, it is better if you will just remember this definition from graph only. Okay. Now this is the complete definition. What is this? Let fx be a real valued function defined on this interval. Okay. Fx is said to have the maximum value in this interval. Okay. If there exists a point in this interval for which this point have the maximum value. Okay, the same thing which I have explained you in the graph, the same thing is written in this statement, but in a somewhat a complicated form. So in such a case, this number FC is called the maximum value of fx. So we can write this, we can say this FC is the maximum value of the function. Maximum value of fx. Okay, from the graph only you can understand this. And this point C is called the point maximum value of f in this interval. Okay, so please note down this definition and remember the graph. From the graph, you can easily understand this topic. Please raise your hands once it is done so that I can change the slide. Abdul, Fahad, Rifat, and please raise your hands once it is done. Okay, Fahad, good. Okay, Zad. Okay, Fahad. Okay, Rifat. So I guess everyone has done this. So we will move to next slide. Please note down this graph. Okay. Again, raise your hands. Then we will start the minimum value. Is it done? Everyone, please raise your hands when it is done. Okay, Rifat, good. Okay, Fahad, good. Okay, Zad, very good. Abdul, is it done? Okay, great. I will check the next topic. Minimum value. Okay, so let me draw the graph here. Maxima and minima is a very lengthy topic. Okay, so it will take more than 3 classes, 3 or 4 classes. So suppose we have this y, this x, and
So
this
is
is,
this the last topic of this chapter?
yes, this is the last topic. Okay, here you have this point C. So at this point C, we can see that the function have the least value. Okay, so at this point, the function have the least value. You can see from the graph only. So this is called the minimum value of fx, minimum value of fx. Okay, and this is called the point at which the function have the minimum value. Function have the minimum value. Okay, fc minimum value of fx. What is this point? Point at which the function have the minimum value. Okay, same thing is written in this point. Let fx be a real valued function defined on this interval. Fx is said to have the minimum value in this if there exists a point such that fx is greater than or equal to fc. Okay, so in such a case, this number is called the minimum value. So please note down this. Raise your hands once it is done. Then I will change the slide. Okay. Okay, Fahd, very good. Abdul, Rifat, Zad, is it done? Okay, Rifat, good. Abdul and Zad, is it done? Um, Today we will not do any question, okay? But I just need to complete the theoretical part so that from tomorrow we can start the question on this topic. Abdul and Zad, is it done? Shall we start next? Okay, sir. Okay, Abdul. Okay, Zad, very good. Next one. Okay, then please note down this. Okay. So please again raise your hands once you will note it down this graph. Okay, Fahd. Okay, Fahd. Okay, Zad, very good. Abdul, is it done? Abdul, is it done? Should we start next? Abdul, I'm just waiting for you. So once it is done, okay, great. Okay, now next topic is extreme value of a function. Okay, so from the name only, you understood that what is extreme value? The maximum and minimum value are called the extreme value. So let fx be a real valued function defined on this interval. Fx is said to have the extreme value in this interval if there exists a point such that fc is either a maximum or a minimum value. Okay, so if a function have the maximum or minimum value, then we will say that, okay, sorry, a function have a maximum or a minimum value, then such point is called the extreme point, and such value is called the extreme value. So when we will say that a function have the extreme value, when it have a maximum or a minimum value. Okay, so if a function have a maximum or a minimum value, then we will say that the function have a extreme value in its domain. Okay, the number, this fc is called the extreme value, and the point c is called the extreme point. So I hope this is clear. Nothing is there in this point. Extreme means maximum or minimum value. So please note down this. Again, please raise your hand so that we can start the next topic. Okay, Fahd, very good. Abdul, Rifat said, is it done? Good said. Abdul and Rifat. Okay, Rifat, very good. Abdul, is it done? Okay, very good. Let me check the time. We still have 13 minutes. Okay. These questions we will do later on. There are many types in the maxima and minima. So shall we start the next topic right now, or do you want to do this tomorrow? Okay, there's a new topic. This is a very, very important topic. Okay, Abdul. Okay. So you're saying right now, please check here. Local maxima and local minima. Okay. So okay. We will try to understand this from the graph. What is local maxima? Till now, we have done the maximum and the minimum value, but here they are saying local maxima and local minima. Local minima. Okay. So we have this graph. Okay. Now suppose we have this graph. If we will check this point, if we will check this point, this one, okay, let this point be C1. So if we will analyze this value, then this value is greater than the neighboring value. Okay, this value is greater than the neighboring value. If you will check the left side, you will check the right side. And at this point, you have the value which is greater than the neighboring points. The value which is there because of neighboring points. So this point is called the point of local maxima. Local point of local maxima. Okay. Please remember, local maxima is not the maximum value of the function. At the point of local maxima, you do not have the maximum value of the function. Or we can say local maxima is not the maximum value of the function. As you can see that, okay, this is local maxima. Now we will analyze this point. Let this be C4. If we will check the value at this point, that at this point, the value is lesser than the neighboring points. If you will check the left side, and at this value is less than the left side value. If you will check compare with the right side value, then this value is less than the right side value. So at this point, the function have the value which is lesser than the neighboring point. So this point is called point of
Local minima.
local minima. So I'm again saying that local maxima and local minima are not the minimum or the maximum value of the function. If suppose check this one, this is what? This is a local maximum value. This is local maxima. And what is this? This is local minima. As you can see from the graph, even local minima is greater than the local maxima. This is the local maximum minimum value, but this local minimum value is greater than the local maximum. So that means local maxima is not the greatest value of the function. Local minima is not the least value of the function. Then what is local maxima? Local maxima is a value which is greater than the neighboring point. Neighboring points means you don't need to go till here. No, the neighboring point is only this one, only this one. So if we are saying that this is the local maxima, so that means this value is greater than the neighboring values. Similarly, who can tell me? Abdur, can you tell me this one? This is what local maxima or minima?
Local minimum.
This is local minima. Very, very good. Okay, so this is what local minima. local minima. So I write a point here. It is C2. Next, Fahad, this point, this is what local maxima or minima?
Local min
Local minima.
Local minima. Very good. Okay, this is local minima. Local minima. Okay, if this is local minima, then this point is called the point of local minima. Similarly, this one. This is what?
Local minima.
This is also local minima. Local minima. Okay. Then next one. Okay. Who can tell me? Z. Z, can you tell me what is this? Z, this is local maxima or local minima?
Maxim.
Maxima. Okay, local maxima. Rifat, the next, so this point we will say this is C3. Rifat, this one, this is what, Rifat, local maxima, minima? Rifat, this is what? Maxima. Very good. This is local maxima. Okay. So because the value is greater than the neighboring point. Rifat, this one, this is what? This is local. Again, this is local maxima because the value is greater than the neighboring point. So I hope this is clear to everyone that what is local maxima minima. It is not the greatest or the least value. Local maxima means value is greater than the neighboring values. Local minima means the value is lesser than the neighboring values. Okay, now, but if we will analyze this one, if we will analyze this graph, okay, then at this point, if I will draw a tangent, then the tangent will be like this. So if I will find the slope at this point, f C1, then who can tell me what will be the answer? Anyone can tell me what is f dash C1? Very good, sir. That is correct. Abdur, Fahad, and Rifat, can you tell me what is derivative at this point? Please check here. This tangent is parallel to x-axis. If a line is parallel to x-axis, then what is its slope?
0.
0. So at this point, the slope is 0. Okay. So similarly, this one, f dash C2, this is what? Again?
0.
Again, this is 0. Similarly, if you will see this one, f dash C3, this is also 0. This one also 0. What is this? This I will write C5. This is 0. Okay, at this point, who can tell me this point is what? F dash C8. Who can tell me at this point, F dash C8, what the value we will get at this one? This is quite different. So please think again what we will have the value at this point. We have done this graph in differentiability. So anyone can remember that point. We have discussed some point in differentiability. So anyone can tell me at this point, what is f dash C8? If we have a corner point, then the function is differentiable at this point or not?
It is not differentiate.
Not differentiable. Okay, so here we have a corner point. So that means if you will differentiate at this point, then it will not be differentiable. So we will say that f dash C8 is not defined. Why it is not defined? Because it is a corner point, and we already know that at corner point, our function is not differentiable. We have discussed this point in differentiability. Okay,
yes, in critical points.
Sorry, Abdul.
So in critical points, you actually.
Yes. This I want to explain this to you. That if very good, Abdul, you understood this. So if we will see this point, f dash C1, this is 0. And if we will see this point, f dash C8, it is 0. So that means local maxima and local minima will occur at which point? At the local maxima and local minima will always occur at which point? At the critical point. These are what? These are the critical point. What are the critical points? At which the derivative is 0 or the derivative is not defined. Okay. What are the critical points at which the function, at which the derivative is 0 or not defined? We have already discussed. So this is your critical point because at this point the function is not differentiable. This is your critical point because here the function, here the derivative is 0. So the local maxima and local minima will occur always at which point? At the critical points. Okay, from the graph only you can understood that these all are the critical points because here the derivative is either 0 or the does not exist. So these are the critical points. So I will write here local maxima and local minima, local maxima and local minima will occur at critical at critical points. Okay. I hope this is clear to everyone that why it occur at critical point because we understood this from the graph. So I hope this is clear to everyone. I'm just going to change the slide. We will check this that what is mentioned here. Let f be a real valued function. Okay. C be a point in its domain. Okay. C is called the point of local maxima if h is greater than 0, such that fc is greater than fx for this. So these points are the neighboring points. So what they are saying in this point that fc, if this is a point of local maxima, if fc is greater than fx, x line this point. So this represents the corner point. So if you have any confusion in this statement, then it's fine. Just understand the graph. Okay. The same thing, value of f is called the local maximum value, which we have already discussed in the graph. This point is called local minima if fc is less than fx, or x belongs to this. The value fc is called the local minimum value. Okay. So please note down this, confirm me, then I will change the slide, note down the graph, then your class will be over. Tomorrow we will continue this one. Everyone, please raise your hands once it is done.
So drawing graph will be better.
Yes, yes, drawing graph will be better, but please note down this point, okay? Whenever you will get the time, please read these points also. But if you understood the graph, then it is more than enough for you. You don't need these things. Okay, sir, very good. Abdul, Fahad, Rifat, is it done? Okay, Fahad, good. Abdul,
No, sir.
okay. Okay, Rifat, very good. Okay, Abdul, please let me know once it is done.
So what is h is greater than 0?
H is a value which is greater than 0. Okay, so H can't be negative. Here they have assumed a value which is greater than 0. or it is better if I will say that h is very, very close to 0, greater than 0, but close to 0. Okay. Okay, Abdul. Good. Okay, so please note down this graph and again raise your hands once it is done. Okay, Zed, very good. Okay, so Zed, please complete the assignments. Okay, and if you wish, then you can drop, or if you have any doubt, then we can discuss. I will share the test paper after the class. Okay, sir? Okay, I love this. Please raise your hands once it is done. Okay, Rifat, very good. So Rifat, if you don't have any doubt, okay, then if you wish, you can drop off. Okay, you're welcome.
Sir, that last point C8 is the corner point, right?
Yes, this is a corner point as well as this is also a corner point. This is a corner point. That's why I've written it is not defined, but yes, it is a local minima.
Okay, sir.
Okay, the derivative is not defined. This is not differentiable at this point.